I'm delighted that this subject has piqued your curiosity because it's piqued my curiosity for many years now. But I wanted to start by telling you about something that happened to me last week when I was on the tube. I was enjoying my morning latte and I saw this headline in the New Scientist. AI achieves its best ever mark on a set English exam. Interesting, I thought. So we've got our AI passing exams now. That's interesting. And I think it's significant for 3 reasons. And they're the 3 things I want to talk to you about this evening. Firstly, I think it demonstrates the power of AI. We can now build AI systems that can learn our knowledge-based curriculum. If we have a system that can pass the English exam now, give it a few hours and it will have taught itself to pass it again and again and again, getting ever higher marks. Secondly, I think that headline was interesting because it's a headline at all. If we think about it, exams are the perfect territory for AI, or at least most of the exams that we set at the moment. They are a very nice task for an AI algorithm. So the fact that it's news makes me worry about the extent to which we understand what AI can and can't achieve. And thirdly, I think that headline draws our attention to the fact that we do now have AI that can achieve what we are asking our students to achieve at school. And that's something we need to take very seriously. Because if we have these machines that can pass our exams, is that really what we want our students to be learning to achieve at school? Perhaps we need to rethink exactly what it is we value in our education system, because we do now have these very smart machines that we've built in our own image, but in a particular image of the parts of our intelligence that we particularly value. And that's the thing that I want to focus on tonight. So 3 things, and those 3 things will come up again and again as I talk to you this evening. But first of all, what is this AI? What is this thing that's bringing about these transitions and these headlines? And we hear about it all the time. So what is it? Well, the basic definition of artificial intelligence could be something like this, that it's machines that are capable of doing actions, behaving in ways that we would think to be intelligent if they were being done by humans. And that's a very general definition. But if we take that for the moment, that's a good starting point. And we need to remember that although we have that lovely piano-playing robot, and you'll have seen many, many movies and read science fiction books where AI is doing amazing things, it's not just in the future. We use AI every day, from our voice-activated interfaces, things like Alexa and Siri, to the passport gates at the airport, to navigation systems in the city. We are using artificial intelligence. Every time we search on Google, there's some AI working there in the background. So it's not just the stuff of the future. It's not just the stuff of science fiction. It's here now, and we're using it all the time. And that's important to remember. Whoops. But just take a step back 63 years ago. It's true that as humans, we've had many dallyings with building things in our own image, often little robots that were mechanical and looked like humans or looked like other things that we value in the world for many centuries. But when we started really looking at artificial intelligence, so not just mechanical artifacts, but things that were intelligent, the real start was the Dartmouth College Conference in 1956. And I dwell on this because it's really important. Because if you look at that statement, that's the statement that was the start of the really serious studying of artificial intelligence. And it's really quite arrogant. Every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. And once more, we think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work on it together for a summer. Yes. Well, we had some quite interesting early breakthroughs. We developed some systems that were expert systems that were quite good at diagnostics in medicine. But the problem with systems like this was that they were based on a set of rules. A patient would present themselves with a set of symptoms, and the rule base would chunter away and match the symptoms to a potential diagnosis. The problem with systems like that is that they don't learn. And so you have to program everything in at the start. So if perhaps we learn something new about a disease or about symptoms that may match to a disease we hadn't thought of previously, we can't update our knowledge base without explicitly altering the program code. So this was AI that didn't learn, based on rules, and a certain sort of pattern matching where you match the start of the rule with the conclusion of the rule. But then this happened. In March 2016, we had the moment when Google DeepMind put forward AlphaGo, a deep learning AI system that was able to beat the world champion Lee Sedol at the game of Go. And you can see Lee Sedol up there, head in hands, at the moment that he realizes he is going to be beaten by an AI algorithm. And this can seem like magic. How is it that this very complex game can be won by an AI algorithm? It's impressive, but it isn't actually magic. It's the result of a perfect storm. And this perfect storm is very important for all of those three areas that I identified earlier. It's the perfect storm that is the immense amount of data that we can now collect as people interact in the world, combined with years and years of careful research to develop very sophisticated machine learning algorithms that process that data to produce results. In the instance of AlphaGo, those results are being able to play Go, and affordable computing power and memory. When I first studied artificial intelligence a little while ago, if we wanted to run a program of any size, we had to do it overnight because we just didn't have the computing power. We could do that in a split second now. So this combination of those three factors, lots of data, really sophisticated algorithms, and this affordable processing power and memory means that we can now achieve things like AlphaGo. And they are very smart. But they're smart in a very particular sort of way. They're smart in a way that relies upon masses of data. And this is why the phrase data is the new oil has been put forward, and it certainly is the power behind artificial intelligence. You need the three factors, the data, the algorithms, and the power, but you certainly can't train machine learning algorithms without that data. But data, just like oil, is crude. Unless it's cleaned and refined, it's worthless. And that's something that's very important to remember. The number of people who I meet who come and say, oh, I've got masses of data rows, can we do some machine learning with this? And then you start to look at the data and you realize, well, yes, you can, but we've got to do a lot of cleaning and organizing before we can actually apply the AI algorithms to that data. So it's not just data in and of itself, it needs some processing first. And it's important to remember that machine learning, just like those old rule-based AI algorithms that we used for our diagnostic systems, is still just pattern matching. It's very, very clever pattern matching, but it's still really essentially pattern matching. When I stand in front of the e-passport gate at an airport and I've put my passport down on the screen and I'm standing there in front of the camera, there's a lot of processing going on to see whether the information in my passport and my face in front of the camera have enough common features that it can say, yes, this is Rose Luckin, and either we do want her to come in or we don't want her to come in, but it is Professor Rose Luckin. So it's still just pattern matching. And this is what's really important to remember. It's very smart, but it's not as smart as we are. So if I say to you, are you an empathetic friend? How well do you understand quantum physics? How are you feeling right now? Can you meditate? You can answer those questions without any problem at all. And even if you don't know much about quantum physics, you know you don't know much about quantum physics. You might actually know more than you realise, but you're able to come up with a well-justified answer to these questions. Even if you can't meditate, you probably think you could. And you're right, you could learn to meditate. Really hard for AI. So, important to remember that the artificial intelligence systems that we've built, particularly the ones that use machine learning, are amazingly powerful. And they are intelligent, but in a very particular sort of a way. Whereas humans are intelligent in many ways. And it's extremely important that we recognise the differences. Perhaps we don't value all of our human intelligence quite enough. And perhaps that's somewhere where we might need to think a little bit differently. But we certainly want our humans to complement the artificial intelligence, not just to try and repeat it. And that's a very important factor to bear in mind when we're thinking about education. So, 3 points, as I said right at the start. 3 real implications for education. And I'll look at the reality and the potential of these. So first of all, we can use artificial intelligence to tackle some of the big educational challenges that we face. From achievement gaps between students who perform well in school and students who really struggle, to global teacher shortages, which I think are estimated to be 69 million now by 2030, just to deliver primary and secondary education. And I don't mean by replacing the teachers with AI, I mean by assisting the teachers through AI, helping students with special educational needs, physical disabilities. We can do so much using AI. So that's my first point. Second one, educating people about AI. And this is also really important because, as I've said, we use AI all the time. So it's really important that people understand enough about AI to be able to use it safely and effectively. They don't have to be able to write computer code. They don't have to be able to understand the nuances of the type of algorithm that's processing the data. But they do need to understand enough about what AI can do and can't do to be able to use it effectively and to keep themselves safe. And then thirdly, what do we need to do now that we've got these AI systems that can do the things that we've cherished in our education systems for so long? What should we do about this? How might we need to think about our education systems so that we can better prepare people for what is affectionately referred to at the moment as the 4th Industrial Revolution? So, important to note that I don't see these as 3 separate implications. They're all interconnected. Because if we help people to understand enough about AI to use it effectively, they can use it effectively to support their learning, and if they're teachers, to support their teaching. And they can help us to educate people about AI, to bring more people on board with AI. And that way, we start to get much better prepared for the immense amounts of changes that are happening across the world, not least because of AI and automation. So it's a virtuous circle where one achievement would build on another and move forward together. So it's important that we see them as 3 interacting elements, not as separate elements in and of themselves. But let's start with the reality of what AI can do for us at the moment. And here, I think we need to start with a friend of mine from the US who's going to tell you in a very small amount of time, something important about AI and education. So I'm going to hand over to
Part of
Lewis.
what makes it very easy for people to access is that it just runs in any web browser on any device that basically supports a microphone. A student in Peru, if they want to learn English, they pull up their laptop or their tablet, they bring up a web browser, they connect to the N-Skill Sim server, and then up comes a role-play simulation, a character on their screen, and then they can just start talking with that character and it will respond to them.
What do you do for fun?
I spend a lot of time playing sports.
Where do you play soccer?
Sometimes I go to Super Sports 7 over on Center Street.
As learners are interacting with N-Skill, it's constantly collecting data of what responses the learners are giving. And so we use that data to continuously retrain and improve the AI. It's really been a game changer, this ability to collect data and then use it to improve the performance of the platform.
Thank you, Lewis. There he said it. It's really been a game changer, this ability to collect and process this data. And that English tutoring system is a very nice product that's used in various different parts of the world. This is a product that's homegrown from a London-based company called Century Tech. It's a machine learning tool, platform, to be used in schools and colleges to provide personalised education to students so that each child can move on at their own pace with carefully designed feedback. Teachers can add their own curriculum resources to the platform, and they can also record their own feedback for students. We also have systems such as this, which is one of the many recommender systems, as we call them. So you know when you use Amazon, it'll tell you, people like you who've ordered this product also ordered these, or we're recommending this film or this product or this book for you. Well, this is a more sophisticated version of that, whereby we have systems that can use AI to recommend resources to teachers to use with their students or to learners, as this one does, to suit that particular learner's need. But it's not just in curriculum areas. We know we can build systems that can tutor people in core curriculum areas, particularly science, technology, maths and language learning. But we can also help people to build their cognitive fitness, which if you think about what's happening in the world, there's a lot of change. Change is stressful. So more than ever, we need our cognitive fitness. So this is a tool called My Cognition. I bought it from my family for Christmas, as my son in the audience will bear testament to. And it helps you to develop your attention, your focus, your executive functions. You complete a test and it evaluates where you are, and then you play a game called Aquasnap here that gradually individualizes your game playing to try and develop your cognitive fitness so that you have that kind of resilience that you need for the modern world. And just in case you thought AI was only for adults and grown-ups, this final example is one for babies. This is from a company called Oya Labs, and it's a little monitor that sits in the room and analyses a young baby's movements, well, maybe not speech, noises, sometimes speech, as they develop, and provides feedback to parents about how they can scaffold and support their child's development. So we have lots of things available here and now that use AI to support learning. Specific subjects, cognitive fitness, young, old. It's here. We know we can do it. But what about the potential? You remember what I said about data being the new oil and Lewis saying it's a game changer. And I also said that it needed to be cleaned and refined to make it the power behind AI. Well, what's really interesting is that that same data, if we clean it and we process it judiciously, can also be the power behind human intelligence. If you think about the ways that we interact in the world, okay, some of these are using technology. So we have our very amusing and witty Apple Siri here, but we also have wearable technologies, jewelry, good old-fashioned interacting with a keyboard, observational technologies that capture data as we interact in the world without us even knowing about it. They're are enormous riches of data that can and are being collected about us as we interact. Well, how about if we use these to support our learning needs rather than just to try and make us buy a particular product or to persuade us to vote in a particular way? We could use this data for good. And that's where I see the real power of AI for human intelligence. Yes, data is the new oil. Yes, we need to clean it in order to extract value. But most importantly, to extract that value, we need to apply what we know about how human learning takes place and how good teaching takes place in the way that we design the algorithms that process that data. Because if we get that right, then we start to open up a whole new world of what I call an intelligence infrastructure. So generally when we talk about AI, we talk about specific products, as I just did when I talked about Alelo, or rather Lewis talked about Alelo's N skills and Century and Oya Labs. But actually, if we get it right, it's about an intelligence infrastructure that can empower everything we do, whether it's our interactions as humans, which are incredibly important, whether it's interactions through our smartphones, as we learn through books, at work, on screens, through robot interfaces, through virtual and augmented reality. These are just interfaces to that intelligence infrastructure that if we process it appropriately and if we understand enough about human learning to interpret that processing, can help us be even smarter. So yes, data can be the power behind human intelligence, as well as the power behind artificial intelligence. And as I said earlier, it's not just for the able-bodied. Intelligent exoskeletons to help profoundly disabled people. Glasses that can help the blind to see. These already exist. Technology in our bodies and on our bodies. Intelligent implants. Reading the brain. Using the brain to control technology without even needing to move, just thinking about what you want the technology to do. This is all possible. And when you build it on top of an intelligence infrastructure, it's a real power for human intelligence, if we get it right. So that's where we can use AI to help us address some of the big challenges in education. My second point, educating people about AI. And this is important for many reasons. We want them to be able to use those artificially intelligent technologies effectively, but we also really need them to keep themselves safe. You could look at what I feel we need to help people understand about AI in these three categories. So we need people to understand enough about AI to be able to use it effectively in an AI-augmented world. We certainly need people to understand something about the ethics of AI, but we don't need everybody to understand the real detail of that. But we do need some people to go into that in tremendous detail to make sure that we keep people safe. But because regulation will never be enough, because there will always be people who want to do harm, we do need everybody to understand enough in order to keep themselves safe when the regulation isn't quite up to speed. Oops. And we need some of the world to have a really good, deep understanding of the technical details of artificial intelligence so that they can build the next generation of AI systems. But it's not everybody. I worry at the moment about the huge emphasis on coding. I love coding. I don't get to do much coding these days, but I could get lost for long, long hours coding when I was doing a lot of coding. But actually, that's the kind of end skill. What we actually need is people to understand how you design the algorithms and how you design the systems, select the data for training, the much more sophisticated skills than actually writing the code. That's the bit we'll be able to automate. So we do need to make sure that it's at the right level that we have people understanding enough about AI. And I'm afraid we do need to think about what's the worst that can happen. Because, as I say, there will always be people who want to do harm, who want to make lots of money. And there are many vulnerable people in the world, and as educationalists, we have to make sure that they're protected. And I find it quite useful when thinking about this very complex area of ethics and AI to break it down into 3 core components. As with all technologies, there's input. As I said previously, machine learning relies on data. So that data is the input to the processing that builds the intelligence. That input might be something of our data that we've agreed to being used. It might be something we've spoken, it might be something we've entered as we've been buying something online, but it could be facial recognition as we're going about our business in the world. Have we given permission for that data? Is that data being stored responsibly? Do we know what that data is being used for? If we've given consent, is it really informed consent? Did we really understand what was going to happen to that data? Who has access to that data? All of these questions are really important. We must make sure that we have regulations that keep people to order if they are using data. And I believe education is a special case that needs particular attention, because if we want people to learn throughout their lives, we want them to be interacting with education, so we better make sure that we protect them. And then there's the processing that happens. So we've got all this data. What about the processing? Are the algorithms that are processing this data trained on representative data sets? Or are these biased? You may remember reading about a recruitment bot that had to be shut down only a few hours after starting work because it only sought male employees, because the data set that it had been trained on had biased it towards male attributes. So we have to make sure that there's no bias either in the way the algorithm is written or in the data that has been used to train it. And finally, what about that output? Is it genuine? Is it fake? Is the output actually there to entice more information from the learner? I was reading on a recent trip, I picked up a copy of MIT Tech Review at the airport, and I was fascinated to read a story about President Trump speaking Mandarin. Did you know Donald Trump could speak Mandarin? I didn't. Well, he can't, of course. But it was a report of a visit to a tech company in China where, of course, they'd produced a perfectly plausible-looking video of Donald Trump speaking Mandarin. The point is we can do these things with AI. So we even need to think about the outputs, to think about whether they're genuine. Are they manipulating us? There are parts of the world where when a child is being shown a particular historical account, their facial features, changes, are subject to AI facial recognition systems to see if they are reacting in an emotionally appropriate way to the historical account that they're seeing, to make sure they are reacting in the way that the particular political party in power wants its citizens to react. So there is a minefield of problems that we have to face, particularly if we want to build this intelligence infrastructure for good. And I hate thinking about the worst that can happen, but I'm afraid some of us have to in order to make sure that we protect people and they get the best from AI, not the worst. And that's why we founded the Institute for Ethical AI in Education, because we believe education's a special case. There are lots of very good establishments looking at data and ethics and AI and ethics, but none of them were focusing on education. And we think education needs special attention. Because regulation will never be enough. We need to educate people about AI as well as to regulate to help them be protected. So, my third point, changing education so that we can focus on human intelligence and prepare people for an AI world. And this is a very challenging area because people tend to feel very passionately that they understand education and education should be a particular way, perhaps because they were educated in a particular way and it worked for them, so, hey, this must be the right way to do it. So I think this is perhaps the most challenging of the 3 areas. But we know from many people, for example, the World Economic Forum, that we are now facing what's affectionately referred to as the fourth industrial revolution. And what this means is that there are many changes happening across the world, including automation in the workplace, the onslaught of AI, that mean that we need to rethink the skills, the abilities, the expertise that we need in the workplace. And obviously that has huge implications for our education systems. Now, some media coverage is enormously positive. This is a piece of work that amused me when I was in Australia a couple of years ago, a piece of research, the link is here, done by alphabeta.com, that suggested that actually we were all going to have 2 hours more a week because 2 hours of our tedious work would be done for us by AI. I like that one. The workplace is going to be safer, we're going to be more satisfied with their jobs, and we're going to earn more money. Hey, who wouldn't want that future? Perhaps slightly optimistic. And then there are many, many reports coming out. This is just one of them. Every week I seem to see a new one that appears that's trying to predict exactly what's going to happen. So this is one from PwC that came out last year called Will Robots Really Steal Our Jobs? And if we look at this, transportation and storage, looks like you're pretty doomed. Education? No, hey, we look like we're not going to be subject to too much automation. Now, I actually think this is a bit misleading because I think the role of educators is going to change enormously, but I don't think we're going to be replaced by AI. And one thing's for sure, whilst there's very little consensus about precisely where the job cuts will hit, there is consensus that there will be big changes, but also that education levels make a huge difference. People with higher education levels are least likely to suffer through automation and AI augmentation in the workplace. So education is as important as ever. And obviously there are differences, gender and age, but education is clear and there is a consensus around this. So we certainly need to do something. But you know, all of these reports trying to predict the changes, for me, are a little bit like driving in fog in a city that you've never been to before. You don't really need a map. What you really need is to know that as a driver, you're alert, you can see well as anybody can do in dense fog, your car's reliable, your brakes are good, steering's accurate, you're not tired, you're alert, you're hearing, you're not listening to too much loud music so that you can hear if there's a truck coming towards you. These are the things that really matter. And so I think the equivalent for us in the current situation is rather than trying to make all these predictions, which historically the evidence suggests we're not terribly good at, it might be better to think, well, what is it that we need in and of ourselves to move forward effectively through this fourth industrial revolution? And so I've written about this at length in this book, Machine Learning and Human Intelligence, and I can only scratch the surface this evening. But basically, I think we need to reevaluate exactly how we conceive human intelligence. Yeah, we need domain knowledge. We need to understand some subjects. But we really need that understanding of maths, physics, chemistry, English, geography, history to be interdisciplinary. Because most problems in the world today are not solved by one discipline alone. They need people working across disciplines, able to communicate with each other, able to understand how to synthesize and bring together multiple disciplines. Then we really need to know what knowledge is. I call this meta-knowing. We need to know how you know if something is something you should believe. When somebody tells you something, why should you believe that? What's good evidence? What's the kind of evidence that will help you make an accurate judgment about whether something is true or not? It's the old-fashioned term epistemology comes to mind, and personal epistemology. But it's actually about having a sophisticated understanding of what knowledge is, where it comes from, to know that it's not something that you're just given to remember and regurgitate. It's something that's relative and that you must understand. Then there's social intelligence. We really need to understand how to interact together, how to work together, how to solve problems together. And as I say, we need to do that across disciplines. And we need to understand ourselves. When I talked earlier about the limitations of artificial intelligence, I said to you, can you answer the question, can you meditate? Can you understand something about your thinking? And this is something that AI finds hard, but we can be good at. We're not necessarily always very good at it, but we can be. Emotional intelligence. Wow, do we need emotional intelligence? Something very hard for AI to achieve. It can simulate it, but it can't actually be emotionally intelligent. And contextual intelligence, to understand that we are subjective, physical humans in the world. We smell, we feel, and all of those things are part of our intelligence and part that's very hard for AI. And we need to add all this together into what I call perceived self-efficacy, which relies on us understanding precisely and accurately what we do know, what we don't know, how we can learn, how we can work with other people to learn, how those people are feeling, how we're feeling, and how we can effectively work together. If there was ever evidence that our current education systems do not prepare people well in these 7 areas, I look at what's happening in our government at the moment. I think if we had more emotional intelligence, more social intelligence, and more ability to do collaborative problem solving, we might be in a much better place than we are now. So being human is fundamentally important, but it's often the things that we underestimate about our intelligence that are the ones that actually we need to start valuing more. If I ask you to look at these images, and I would ask you to look at these images, and I'd ask you to look at them and try very hard not to look away. How do they make you feel? I'm guessing they make you feel human, and I'm guessing that you recognize that these are images of suffering. Suffering is something it's very important for us to understand because it makes us human. In the words of Noah Yuval Harari, if you want to know the truth about the universe, about the meaning of life, and about your own identity, the best place to start is by observing suffering and exploring it. What AI will ever be able to do that? It's important to ensure that we still can. Now I ask you to look at these images and say, what do you see? And hopefully you see something more fulfilling. Hopefully you see love and empathy and compassion, seeking human kindness. I was very struck by Jacinda Ardern recently in her amazing reaction to the terrible shooting in New Zealand. But I was fascinated when I read in the Guardian article about her on Saturday that she said, when asked, that she hadn't had to think long about how to react. It had been instinctive. I would suggest that it's not as instinctive as just immediately available. I would suggest there's a lady who's very emotionally intelligent. And that's the kind of intelligence we need to make sure we develop as part of our education systems, because that's what will set us aside from robots and artificial intelligence. So very, very important. It's important that we value our human intelligence more than ever in this AI world. And we need to see it not as separate elements, but as interwoven elements. Academic intelligence, yes, but interdisciplinary academic intelligence, social intelligence, meta-knowing, meta-contextual, meta-cognitive, perceived self-efficacy. We need this whole piece It's what makes us human, and it's what will set us aside from the robots. But isn't this the wonderful finesse? AI can help. We're not just on our own. Remember, data, cleaning, applying what we know about human learning means we can build this intelligence infrastructure. We can take all of these data and we can turn it into the information that will help us understand ourselves and our students much, much better so that we can stay smarter. And if you just take this one small example drawn from some work that we've done at the Knowledge Lab, this was a study that we did into collaborative problem solving. And I use it just as a very particular example of the way that we can collect data during educational interactions, not all of which mean that we have students plugged in to a computer. And if we apply what we understand about human learning, we can extract something valuable from that data. So as you can see, we collected data here from students using eye tracking technology. They had markers on their hands so that we could see where their hands were moving as they were working together. Yes, they were working with some technology, so we collected the log data from that technology. We gave them two what we called sentiment buttons in the middle here. So when things were going well, they could press one that was, yay, it's going well. And when things were tough, they could press one that was like, ugh, really having problems here. And they had a little handheld device that they could report back on their progress through. We thought this would be interesting. And hey, we got this kind of a readout. It's not terribly informative. Yeah, we can see when they pressed the sentiment button, we can see what stage they reported they were in collaborative problem solving. We can see something about eye tracking here, but really, it's a mess. This is data without the application of what we understand about human learning. But then when we started to understand what we know from the learning sciences, and this is one small example, we looked at something called synchrony, which had been previously explored, and it had been found that students who look at the same thing, who are moving their hands towards the same thing, tend to collaborate more effectively. And so we applied this frame to our analysis, and sure enough, across the groups of students that we were working with, when we used that synchrony feature, which can be automatically analysed from the data that we collected, and we compared the results of that automatic analysis of our data, looking at the synchrony of gaze and hand movements, it predicted the groups that were effective at collaborative problem solving to the same extent as an independent human expert looking at the collaborative problem solving skills of the different groups we were working with. Now, I'm not suggesting that that on its own is enough. I'm saying that we can identify features that can be triangulated together to tell us more about how effectively people are working together as they solve problems collaboratively. Not with the idea of replacing teachers in this situation, with the idea of giving teachers more information about the groups that they're supervising. So, we need all of these things as part of our human intelligence. But what does this mean for teaching? Well, I think it means that, of course, numeracy and literacy, sacrosanct. We do need people to be numerate and we do need people to be literate. We also need people to understand the basics of AI, not least data literacy. We need people to understand why data is so important for machine learning and how to interpret the analysis of their data. What we do with the remaining subjects, I think, needs to be with an emphasis on what these subjects are, where the knowledge base of these subjects comes from, how we know things are true, and how we can blend them together in an interdisciplinary and multidisciplinary whole. And we need to use techniques like debate and collaborative problem solving to help students apply the knowledge that we hope that they are gaining. And we need to give teachers and trainers time to work with students to build up the complex skills that they need to profit in the future workplace. But this is where AI can help. Yes, we can build AI systems that can provide individualized instruction to students, and it's effective, so let's use it. But it does not replace teachers. It just performs one part of what we want our teachers to do. And then we use our wonderful human intelligence to refine this understanding through those collaborative activities, through that debating. We use our lovely human teachers to help learners develop their social and their emotional and their meta-intelligences. And then we round it all off by using our AI to analyse the data from the interactions that our students and teachers have together, have through their technology, through that intelligence infrastructure. We need to do this, and we need to do it urgently. Otherwise, we really run a risk that we just produce second-rate robots. And that's certainly not what we want to do. I use this picture quite often in my talks. This is the first use of the word robot that I can find. And look at them. It's a dystopian future of robots taking over the world. And you can see they look terribly grim, don't they? But because they're actors playing robots. But now we've had robots that are built in our own image. But if we're not careful, we end up back with these humans playing robots. So we don't want to go back to that. We need to make sure that our humans are human and our robots are robots, but that we understand the difference. But how do we achieve all this? As I come to the close, I just want to give you an idea about how we might achieve this cycle of these three vital components that we need to mix together. I believe the only way to do this is through partnerships. We need to build partnerships between our educational stakeholders if we're actually going to be able to achieve all of those three activities successfully. And as an example of this, I point to our lovely Educate programme at UCL, and some of my team are here, I know, built on the Golden Triangle. And so what is the Golden Triangle? Well, the Golden Triangle came about when I was having a conversation 6 years ago, actually, with some tech developers, Claire Riley from Microsoft and Jim Wynn from Promethean, as it was then, and some academic colleagues, Richard Noss and Mike Sharples, and some educators who'd come to the Institute of Education. And we were having a conversation about why was it that UK educational technology didn't seem to build connections between the research world, the education world, and the technology world. And that's where we came up with this idea of this triangle, where we need to build relationships between these communities, the people who make the technology, the people who use the technology, and the people who understand how you know if the technology is working or not. And it's golden because it's built on evidence, because evidence is what really matters. So in the Educate programme, we help EdTech developers to understand what evidence is. Evidence about existing learning, existing educational technologies, and evidence they can generate about their own product or service. And we do the same for teachers, helping them to understand how to pilot technologies and generate evidence about whether it's meeting an educational need or not. And if we get this right, we can use this to power our AI. We can help our AI developers to understand more about teaching and learning, because at the moment, most of them don't know much about teaching and learning. We can help our educators to understand more about AI by working with the AI developers to develop the AI that we need in our classrooms, universities, and in the workplace. And if we engage those two communities through researchers who understand about evidence, learning, the learning sciences, then we start to get the virtuous cycle of interactions. And that way we can start to achieve these three areas of application that we need to build. The use of AI to solve educational challenges, the prioritisation of human intelligence in our education systems to keep us ahead of the AI, and educating people about AI. Because educators who work alongside AI developers will be far better equipped to help their students understand about AI. So not only do we end up with better AI being used for education, we end up with more informed developers and more informed educators. So, quick summary. AI is smart, but humans are and should always be smarter. There are three ways that I think AI can enhance learning and teaching. Three ways that we must forge ahead with. We need to tackle educational challenges using AI. We need to prioritise human intelligence and value those aspects of human intelligence that are not demonstrable in an exam. We need to educate people about AI, particularly to protect them and ensure that the way AI is rolled out is sound and ethical. And in order to do this, we have to work in partnership. We have to work together to make sure that what happens with AI realises its potential for good and not for harm. And I'm going to stop there and thank you very much for coming along this evening.